Fordham here, and we're going to talk about factoring, and this really should say factoring polynomials. I'm going to make a little addendum to our title here. Now, I put here reverse foiling, and I'm actually going to go through the FOIL process first, because factoring is just FOIL backwards. And I want you guys to see that when we're all said and done, we're actually going to end up with this again. So if you don't remember FOIL, that's okay. We can go ahead and just go through the process again. FOIL stands for first, outside, inside, last. So first, I'm going to multiply the first terms in the two binomials, which would be x and x. When I multiply them together, I get x squared. So now I'm going to do the outside, which is x times 2, which would just be 2x. Then inside, 3 times x, that's 3x. And then last, 3 times 2, that's 6. Now, before I go any further, I want to see if there's anything I can clean up. Looks like I can clean up 2x and 3x. And when I combine those together, I get x squared plus 5x plus 6. And in fact, that's actually going to be our first example. What we're going to do is take this, and essentially we're going to take this polynomial and turn it back into two binomials. Now, you might be asking yourself here, why would we do this? And that's a very valid question to ask yourself. So what I'm going to do is go back to a previous unit where what we did was we kind of worked with a table. So I'm going to go ahead, x squared plus 5x plus 6. That's the polynomial we're working with here. And what I'm going to do is generate a quick table just to show you what we're working with here. So I'm actually going to use -3, -2, -1, and 0 as my 4 points, and you'll see why in a second. So when I plug in -3, this shouldn't take too long, -3 squared is 9, 5 times -3 is -15, and plus 6, that actually works out to 0. Interesting. All right, well, let's plug in -2. -2 squared is 4. 5 times -2 is -10. That leaves me at -6. And -6 plus 6 is also 0. Weird. So if I were to plot those points, I'd have a point here and a point there. Well, let's keep going. -1 squared, that's 1. Plus 5 times x, that's actually -5. So 1 plus -5, that's -4. Plus 6, that's 2. And the beauty of plugging in 0, everything drops out except for the 6, and we'll get 6. So in reality, my graph looks something, 1, 2, 3, 4, 5, just enough points. It actually will look like this. Now, let's go back to the question. Why do this? Well, turns out those two binomials from before give us these 2 points right here called roots. You actually have learned about this already in a different term called the x-intercept. And you can kind of see how there's actually 2 of them. Now, with these binomials that we're working with, there's either going to be no roots, meaning this graph doesn't touch the x-axis. There's 1 root, meaning it just touches the x-axis, or there's 2 in this case. An example of what 1 would look like if it didn't have roots would be like that. And it's pretty clear to see that that graph is never going to touch the x-axis. And an example of where it would just be 1 be something like that, where it just touches it, it doesn't cross. All right, let's go back to our example. More on this stuff later. So we are here. X squared plus 5x plus 6. I'm going to zoom in because I don't want you to get sidetracked with the other example. Okay, what we're going to do is going to seem kind of weird, but it actually almost works every time. We're going to take this number 6 here, and we're going to list out all the factors of 6. Hey, that word factoring is coming back into play. Okay, so factors of 6. What numbers can we multiply together to get 6? Well, there's 1 and 6, and there's 2 and 3. We're actually going to make a quick little table here. And what you're going to do is add and subtract the two numbers together. Well, okay. What's 1 plus 6? That's 7. And 6 minus 1, that's 5. 2 plus 3 is also 5. And 3 minus 2 is 1. What we're looking for is in our table here, when we added or subtracted the numbers together, we're looking for the middle number to appear. We're looking specifically for the 5. And it actually showed up twice. It showed up in 6 minus 1, and it showed up in 2 plus 3. So what you're going to do is you're going to basically start to make your binomials. Okay. And you need to determine which two numbers are going to go there, so that if I were to FOIL it out again, I would get the polynomial we started with. So basically, you can kind of see we are now taking this polynomial and almost going backwards. The only difference is you don't start with it. Okay. Now, which number do I use? Well, there's actually a pretty easy way to do it. You could guess and check, or you could just remember something. If it's in the plus column, you're either both numbers are positive or both numbers are negative. And if it's in the negative column, one's positive and one's negative. Now, there's only going to be one combination that works. There's never more than one. So all we have to do is test it and see. So let's go ahead and plug in for this one. Let's start with 2 and 3. So I'm going to put 2 there and 3 there. The goal is to get positive 5. So is there a combination we could do it where we would get positive 5 and also still get positive 6? Well, if we add them together, it actually works out. And you can see that's the original two binomials we had. The easiest way to check your answer is to just multiply it back out. So you would do first, outside, inside, and last. I'm not going to do that for this example because, well, we already know this is right. Let's try a different one. X squared minus x minus 20. So again, we're going to go ahead and make a table for all the values of just 20. So we're looking for the factors of 20. So we're going to add and subtract them together. Well, there's always 1 in the number. There's 2 and 10. There's 4 and 5. And that's it. Okay. Well, 1 plus 20, that's 21. And 20 minus 1, that's 19. We're looking for 1. Specifically negative 1, but just 1 for now. Since that didn't produce a 1, that can't be the answer. All right, well, 2 and 10. 10 plus 2 is 12, and 10 minus 2 is 8. Again, that didn't produce 1. So we better hope that this produces it, otherwise we got problems. 5 plus 4 is 9. Uh-oh. But 5 minus 4 is 1. There it is. So what we're going to do is we're actually going to go ahead and take the setup of, we know that we're going to be using binomials. So we can go ahead and put them in there. Only one number combination worked, 4 and 5. So we're going to go ahead and put a 4 and go ahead and put a 5. Okay. Now before in the last problem I said if it's in the column where you subtracted them, one number is going to be positive and the other is going to be negative. So now you just kind of have to figure it out. Well, an easier trick. You know that you need a negative, so you make the bigger one negative. If I needed a positive, I would make the bigger number positive. Simple as that. Again, very easy to check these. Requires no effort at all. All you have to do is FOIL. So first times first. So first terms, that would be x squared. Outside, x times negative 5. That's minus 5x. Inside, that's plus 4x. And last, that's 4 times negative 5, which is minus 20. And as you guys can see, I can clean up right here, and I get x squared minus x minus 20. So it worked. This is indeed the answer. Now, this doesn't always work. Again, as I mentioned in the examples, sometimes there's no roots. So what does it look like when that happens? Well, here's a good example. So, example 3, x squared plus 5x plus 3. Again, I'm going to go ahead and make a factor list of all the factors of 3. Well, that's going to be really easy because 3 is prime. So that means it's going to be 1 and 3. But we still need to go through the motions, so let's go ahead and add and subtract it. So we're going to get 1 plus 3, that's 4, and 3 minus 1, that's 2. But we needed 5. When this happens, this means that the problem has no roots, and you're done. You don't have to proceed further. This happens roughly 5% of the time, but you need to be aware that it is possible. If you cannot factor this number on the end here and produce the number in the middle, then it has no roots. Thanks for watching.